All right, so for this next problem, I have good news. The first thing that you had asked for this one, problem number 53, test number 2, was, okay, like logs, how do we do logs again? So I went on this big sort of bender relearning logs because it turns out that logarithms are this thing that I hardly ever use in my life, and I have to relearn basically every time that I want to teach them, and that's frankly kind of embarrassing. Really quick thing that you want to memorize for the ACT, because this will just give you a direct point here, is this little thing, log base 2, that's how you pronounce that, log base 2 of 8, that's how you pronounce that, log base 2 of 8 equals 3. Go ahead and literally like make a flashcard with an index card or something like that to recall that. If you can remember this, you will be able to re-hack how to do logs really easily. Now, a brief explanation about that. All a log is, here, ordinarily we would just write something like 2 to the power of 3 equals 8. And if you say, didn't remember what you had to raise 2 to in order to get 8, you might say something like 2 to the power of what now? Equals 8. Okay, so a logarithm is just a way of writing that out. So you're basically saying, okay, 2 to the power of, you see it's kind of up here, right there, 8, except like you make that whole thing, it's like you make the, yeah, okay. So here's like 2 to the power of, no, what am I doing? That makes no sense at all. That's ridiculous. 2 to the power of 3, let me can I start that again? Okay, so you usually write it like this. To the power of what now equals 8. And then you kind of like put your finger on your temple and kind of massage it around, and then you eventually figure out, oh yeah, it's 3. That's what it is. It's 3. I get that. Great. A log is a way of like saying, so it's like, what equals, what do I have to raise 2 to the power of to get 8? And then you put the word log in front of here. I'm just really getting confused by the fact that this kind of looks like an exponent, but it is not an exponent at all. Okay, very good. That's what a log is. It's like a backwards exponential where what you're trying to solve for is the really icky part, the exponent part. If you forget how to do this, but you can type something into your calculator, there's another trick thing to write in, which you can write in your calculator, your graphing calculator. It has a log button. However, it only has a log base 10 button, unless you get really fancy about it. So you hit the log button, and then you type in a number that has a lot of zeros after it. So for example, 10,000. So literally, like right now, pull out your calculator, type in log 10,000, and then guess what it is going to equal. The answer that you'll find for this is 4, and that makes sense because 10 to the power of 4 equals 10,000 because there are 1, 2, 3, 4 zeros after 10,000. If you don't remember the number 10,000, that's great. Just type in log. Remember that logs are always secretly base 10. And write in, I don't know, like a zillion. And then you can have it tell you what you have to raise 10 to the power of 2 to get to the really big number here. And it's going to say 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a billion. Equals 9. Great. This is a thing that you can type in your calculator just to kind of remind you, oh yeah, it's this to the power of whatever the answer is gives you this number that you typed in right there. Okay, so if you want to use that, what you can do is think of this problem right here as log based 10, this is a calculator thing, of 1 equals 2x minus 1 over x. The log of this, the log base this of this equals this. There we go. Whew. And you could do that. And you could literally even like type in like, what is log base 10 of 1? You could do that. And actually what you'd find is the answer is 0, so 0 equals that. Now there's a much easier way of doing this though, and I only realized this after I'd done all this log work. And that is to recognize that you don't need to do anything with logs at all. This is literally not even a log problem. Think about it this way. Hey, 10 to what power equals 1? Well, it's an interesting thing, isn't it? Like 10 to the power of 1 equals 10, 10 to the power of 2 equals 100, 10 to the power of 100 equals a Google. But how would you get 10 to what power equals 1? Well, it turns out that there's this law in algebra that, or I guess even arithmetic, that anything to the power of 0 equals 1. I can actually explain why that is. It is, I will just say, sort of beautiful, just amazing. But let's not talk about that right now. Go ahead and just take that on as a matter of faith. So the answer here is 0. So as soon as you see that, you can say, wait, this whole thing in here is just 0. So what I'm left with then is just, hey, 2x minus 1 over x equals 0. Okay, how do I find that out then? I guess I'd multiply both sides by x. Okay, times x. Those cancel out here. 0 times x is just going to be equal 0. So equals 0. Now I have 2x minus 1 equals 0. I'm trying to solve for the x, so I get rid of the negative 1 here or minus 1 here by adding a 1 to both sides. I have 2x equals 1, and then I'm going to divide by that 2 to get the x by itself. X equals 1/2, and oh my gosh, that happens to be one of the answer choices, specifically the right answer choice. So that's all you need to do for this one.